Good afternoon, everyone. I hope you're enjoying the conference as much as we do. My name is Michael Barbero. I'm head of security at the Eclipse Foundation.
And my name is Thomas Neidhardt. I also work at the Eclipse Foundation as a security software engineer.
So today we will talk about GitHub and how to configure it for fun, profit, and security. And the goal of this presentation to give you the tips and tricks for you to better use GitHub for your projects. So we would like to start by stating a couple of things about GitHub that can be annoying or can be hard for you to cope with. First of all, is that GitHub is evolving very fast. They are introducing new features, and especially in the security areas, at a very fast pace. For instance, for the last couple of months, they introduced 45 security features. And of course, not all developers look at the change logs from GitHub to identify what are the new features that you want to adopt. The other thing about GitHub is that you have absolutely no transparency in changes. So when you go to the UI, to the settings, you click on a couple of checkboxes, you enable some features, you change some descriptions and so on, but you don't have any traceability or audit trail of the various changes that you did. And of course, for security reasons or for compliance reasons, not having a clear history of what happened in your repository configuration can be an issue. So that's why for the last couple of months, for the last couple of years actually, we started this project called Eclipse Autodog. You may have heard about it as the self-service also for Eclipse project at the Eclipse Foundation. And the goal is to provide you with configuration as code for your GitHub settings. With that, you have a clear view of the current settings and also the ability to change it with your the developer workflow, the workflow that you are used to use as a developer, so creating pull requests and so on, because everything is as code, so in text files. And of course, as it lets you use PR, pull requests to request for changes or to deploy some changes, you can discuss the changes. So whenever you want to enable a security features or create new repositories and so on, you have the ability to discuss with your peers or with the security team, for instance, if you want advices about the changes that you want to deploy. So as it is configuration as code, of course, you need to store the configuration somewhere. At the Eclipse Foundation, Autodog is configured to look for the configuration file in a specific repository called .eclipsefdend that is stored in all GitHub organizations of your projects. And inside this repository, you have the file with the actual Autodog configuration. Something that So Autodog is not only about the configuration as code. We are able also to aggregate the data, to retrieve the data from all those configurations, and build some dashboards. So this one is the global dashboards that aggregate the data for all Eclipse projects. All the Eclipse projects that are managed by Autodog, but you also have the ability to see the similar dashboard for your own GitHub organization for your project. So on the left side of this dashboard, you can click and expand the organization and see the configuration for this organization and also per repositories. So you can have a clear view of the current security posture of your GitHub organization. So this work has been funded by the Alpha Omega project. If you didn't hear about Alpha Omega, it's a project from the OpenSSF that help open source projects and open source organizations to bootstrap their security initiatives. So we are very thankful for their help in us doing that. So let's now dive into the actual meat of the presentation. The rule number one that you want to avoid when you do open source development is to not leak secrets. Okay, you have one job is to not tell secrets to others. So there are two settings for that in GitHub. The first one is to enable secret scanning, so that GitHub will continuously monitor the state of your repositories and scan the content of the file for secrets. So that's good, but if GitHub is able to look into your repositories for secrets, it means that it's already there. So there is another feature called push protection, secret scanning push protection, that acts before you actually deploy or push the changes to your code. And you will see the messages like that when you push to a branch when there is a secret inside the commits. Of course, you can bypass those protection if you really think that this secret is nothing that you care about, or that it's actually not a secret, that's a false positive, and you can bypass the detection. And here on the right side, you can see how these settings can be enabled in Autodog. So the second rule that you need to comply with, that we really promote the usage, is to keep your dependencies up to date. Of course, you want to update your dependencies as soon as vulnerabilities are detected into your dependencies. So for that, there are two tools. There are the dependables, of course, from GitHub. There is also Renovate, which is another tool that does similar thing, but not from GitHub itself. It's an external app. And you can do two things with Dependabot. The first thing is that you can get security alerts when there are dependencies that are outdated and containing vulnerabilities. So you will be able to see them inside the security tab of your projects. And the second one is the update enabled. So it will create PR for you to help you update the dependency directly in your code. So you will just have to merge the PR to get the update. That side, I will let Thomas continue.
Okay. So another thing that you can do in your repositories, and you certainly should do, is to protect the tags and branches for different reasons. First of all, you would like to prevent that force pushes to important branches can happen by your committers. This is in order to make it clear what's really happening on your repositories, and basically do not hide any kind of history and any kind of action that has been performed on the repository. You also would like to prevent deletion of important tags, especially release tags, because they should not go away. You also would like to encourage reviews in your repository by your fellow committers, so that anything that goes into the main branch is actually reviewed by colleagues and it does not maybe contain something that shouldn't be there, or is maybe has been made by a mistake. And it also it allows you to add an additional safety net for easy checks. So as you know, the Eclipse Foundation has some checks to make sure that any commit that happens on the repositories is from a person that has signed the Eclipse contributor agreement. However, this is not mandatory. So it's just like an indication whether this is true or false. With branch protections, for example, you can actually enforce that. So you can prevent that commits happen on the main branch, or the branch that is protected, that fail these ACA checks. So that's an additional safety net. It's not mandatory, but you can actually do that to further improve your development workflow. A solution in order to achieve that is to either use branch protection rules. So that's basically the old mechanism that is available from GitHub for a long time already. But there is also now a successor. It's called rule sets. It's basically the same as branch protection rules, just like better. It's not only better in sense of available options to bypass rules if necessary, but also it offers many more features that are not there in branch protection rules and will never be there because, they decided to more or less deprecate branch protection rules. So our guideline is that if you enable things like that, if possible, that you prefer rule sets over branch protection rules. They are more or less the same for the standard use cases, and in the long term, they make your life certainly easier. So let's take a look how you can actually define a branch protection rule. So as a first example, it's not that I suggest doing that, but to give you an example how you define a branch protection rule for a specific branch, in this case the main branch, using our self-service approach. So you basically update your configuration file to add a snippet like that, where you specify, I would like to have a branch protection rule for the main branch. If you don't specify any specific settings, then all the settings from the default configuration is taken into account. If you would like to override them, of course, you're free to do so. In this case, I wanted to do that. So in this case, we say the number of approving review accounts we set to 1, because it's a small project maybe, and we would like to add some additional status checks that should be passing before we are able to merge a pull request to the main branch. So on the right side, you basically see the full set of settings that will then be applied. So all the settings that are inherited from the default configuration, plus the settings that we choose to change, to modify in this specific case. So with a rule like this, with a rule like that, we already achieved 3 things. So we prevent forced pushes because that's default, disabled by default. It requires reviews. That's something again that we don't require projects to enable, but of course it's useful also for the project itself. And it also adds a mandatory ECA check. So that also is coming from the default rules. You see that on the right side. So that's actually the top status check here. That's coming from our ECA validation application that is also present on GitHub. So it's relatively easy. So the same thing, of course, you can do with a rule set. So that's also what we suggest nowadays, and we try to push ourselves in the projects that we maintain. That's how it looks like. It's more or less the same, similar options. They are grouped now a bit differently to make it more clear how the different settings are dependent on each other. So that's already an improvement here. As you see on the right side, the options are already a bit more extended because rule sets, as I said, are a superset to branch protection rules. They allow you to do more things than you were able to do with branch protection rules. But in this case, yeah, so that's basically how a rule set looks like that is similar to the branch protection rule that we had before. Another thing that you can do with rule sets, especially, is to protect a specific tags. So of course, if you make releases, you tag the releases, you would like to prevent these tags are deleted at all by accident or by malicious intent. And in order to protect that via a feature of GitHub now with this rule sets that actually target tags. And the rule is relatively simple. You basically say, I would like to prevent deletion of all tags. So there's a specific format that you have to add there to tag all to target all tags. And then you basically say, I would like to prevent deletion. I still allow creation, of course, because I would like to tag certain commits. But I also would like to prevent updates of these tags at all costs. And then there are some 2 specific options there. That's basically just to prevent that pull requests are required and status checks are not required because they are not relevant for this specific tag protection that I would like to add. So that's how it looks like. It's relatively simple for you to add like this to your configuration. And with the current workflow, you can basically do that all by yourself. So adding new stuff to your configuration. If this is approved by project lead in your project, you can merge that yourself. So it's basically a matter of minutes to enable these settings. If you would like to delete something, on the other hand, of course, it needs oversight. It needs additional approval from our side for now. That's something that might change in the future, but this is how we have set up things like that at the moment. Some things that I would like to present, it's maybe not very well known. Not many people use that. So to my knowledge, there's currently 1 Eclipse project that uses that. But I wanted to give you some information that this exists and how this can be used for. It's merge queues. So it's a feature that was introduced by GitHub a while ago. What basically is it? It's if you're familiar with auto merge, it's something like this, but on steroids. So it allows you to bundle multiple PRs together into a single PR, as you can say. And once all required status checks for this separate PR then pass, it will be automatically merged by GitHub. Why is this interesting, or why is this needed? The idea behind it is that if you have very high activity projects with lots of PRs happening all the time, it can happen that if these PRs are separated from each other and then merged into the main branch, post merges can actually lead to build failures or test failures because the changes are not really tested together. So if you have like low activity projects, that's might not be an issue, but if you have like multiple PRs that are being merged on a daily basis, this can lead to problems, and you would like to prevent them by using this merge queues. So maybe you can, if you're interested, you could talk to the guys at the Apoapsis project and get their experience with that feature. They really, they really wanted to have this feature. They want to make sure that we can enable that for them, and they are very happy with that, as far as I understand. So, if you're interested, maybe reach out to them via the chat service and get some feedback from them about this feature. Also, there's one nice UI feature that is available for merge queues. That's not easily visible from the UI, so you need to know the exact URL to access that. It gives you an information about the currently queued PRs in a merge queue and the average time for the last PRs that it took for them to be merged into the main branch, to give you some numbers. That's just like a bonus. Another rule that we find quite useful for every project is you should look at private vulnerability reporting. So that's a relatively recent feature of GitHub for users or reporters to be capable of reporting in a private way security vulnerabilities to a project. You have to enable that for your project if it's not enabled yet. You can do that again with a self-service, of course. It's a convenient way actually to deal with that in a way directly integrated with GitHub. Otherwise, we have cases where people report vulnerabilities via our mailing list or via the GitLab tracker from the foundation. It's up to you what you would like to have. I usually would say if your project is on GitHub, use the available features on GitHub. So that's my suggestion, but it's up to you, to the project, of course, what to do. Another thing that is actually quite a prominent topic in this talk also is ways to secure your workflows. So there are various dangers and problems with workflows on, or GitHub Actions in general on GitHub. It's you have to imagine that because everything is public on GitHub and everybody can create PRs to your repositories. It also means that the attack vector the attack surface of your project actually increases because of that. So everybody can do anything and trying to sneak something malicious into your repository. In order to prevent that, you have to be aware of a few things. First of all, you have to make sure that the default permissions that are granted to your workflows follow the principle of least privilege as a good security practice. Another thing is that if you're using third-party actions in your workflows, you always have to keep in mind that they also might use other actions that you're probably not fully aware. And then the third thing, as I mentioned before, is you might get PRs from anybody, so also from forks, and they might contain all kinds of malicious things, and that you need to handle them differently. What I already said is the goal for this is that we make sure that all the workflows, they only use the permissions that are needed for their action to be performed, that we actually pin all the third-party actions to commit hash in the workflows that we are using them, and that we also understand and are able to deal with PRs coming from forks. So for workflow permissions, so for a long time, the only option that you had was like that all the tokens that are generated by default by GitHub have write permissions by default. That's unfortunate, but that's how it was. A while ago, I think it was like beginning of last year, they added the option to set the policy to read by default. So we highly suggest that to enable that in your project, especially when you start a new project, do that right away. For existing projects, that poses a problem, of course, because it means that all existing workflows have to be adapted. What you can do for each workflow and for each job, actually, you can specify which permissions are really required, and then GitHub will make sure that the token that is being issued to these workflows and jobs have the right permissions. So everything is still possible, but it requires some action. Yeah, so there's an additional option that you can do, but that's also a bit controversial. You can also limit which actions can actually run into your in your organization. So you can limit the actions actually to only GitHub-owned actions. So the assumption is that we trust these actions a lot, because if they are compromised, then we probably have other problems as well. So that's possible, but it's of course also in many cases not desirable, because existing workflows already use so many other third-party options, third-party actions, that enabling this setting would actually require you to rewrite your workflows. So it's up to you, I would say. I usually don't suggest that, but if you would like to be super secure, I think that's something that you should think about. Yeah. So there's also a link to the explanation how you assign permissions to workflows. It's relatively straightforward. Many actions actually also advocate directly what permissions they need. Yeah, that's the way it is right now. As I said before, migrating existing workflows is painful. So strong advice is to already use read whenever you start with something from scratch. Or, for example, you start with workflows in a repository that did not use workflows before. Already use with read. There's an initial hurdle to get over that and to assign permissions properly to your workflows and jobs. But once you get the knack of it, it's relatively straightforward. We also plan to work on tools to make migration easier, but for now there is not really something available that can be used right away. Another thing that is really important for different reasons is you should really make sure that you pin the dependencies in your workflows. Why is that actually needed? I mean, there's the GitHub Marketplace with lots and lots of third-party actions that are really useful. The downside is that GitHub decided to not have a real package manager for these actions. So it means you develop an action, you release it, then it's uploaded somewhere, and it's more or less immutable there. In the end, how GitHub decided to integrate actions is to directly reference the source repository by tag or branch. And of course, tags or branch are not immutable. So it means that if you reference an action, for example, by its version v3, that might be true today, but you might get something else tomorrow. And with all the attacks that have happened in the past, you can imagine that actions that are used by a lot of repositories on GitHub are a very valuable target for malicious actors. In order to prevent that and to mitigate that risk, you should pin. But of course, pinning itself will not solve all problems, because there's also something that you have to keep in mind, that any third-party action that you might use can have transitive dependencies itself. And they might not pin their dependencies themselves. So whatever this action actually does depends on the time it is being executed. We have developed a tool that we also plan to add to our open source project that allows you to look at the transitive dependencies of workflows and to make an educated guess whether it's a good idea to use that action or not. How to do actually pinning? So what you actually do is, many people have done this manually so far. So when you would like to use an action, you go to the repository, you go to the tag or branch that refers to that, check what is the commit hash, and copy-paste that commit hash in your workflow. So that's the way it usually works. There are some tools out there that help you a bit with this. We had the idea that we could automate that to make life a bit easier, and also to make sure that we can do that at scale for all repositories, ideally. So we came up with, we call it now some kind of a policy that you can enable for your project, where you specify, I would like Autodoc to pin all my workflows in all my repositories. And what will happen is that Autodoc will, on a regular basis, check your repositories, check if you have any workflows that are not pinned yet. And if this is the case, it will pin them to the latest version, and then create a pull request that you can review and then merge if you feel this is appropriate. So that's something that we came up with quite recently, and we would really advise everybody to take a look into that and enable that, if possible, for your organization, because it's really useful. Another thing that I would like to mention and discuss a bit today is PRs from forks. I guess everybody has created a workflow that runs automatically if a pull request is being opened and does some fancy stuff. And then the first time you receive a pull request from a fork, this workflow doesn't work anymore. And you don't know exactly why. And you have to dig into the documentation of GitHub and understand why this is the case. And the case is basically that GitHub decided that the pull request trigger for workflows behaves differently when the PR is coming from within the repo or from a fork. Why is this the case? As I said earlier, because everybody can create a PR and do any change. And if your workflow, for example, would reference a secret, a malicious actor could easily extract that secret by adapting the workflow in a PR, and the workflow is then being executed when the PR is opened, and boom, you have a problem. Huh? So the consequence of that is, of course, that such workflows that are executed from PRs from forks, they don't have access to secrets and to any kind of write tokens by default. Actually, there's no way around that. There's a more in-depth explanation in this issue if you're interested in the attack vector and the consequences of that. I don't want to go into detail today, but yeah, it's worth a read. There are workarounds that, but they also have consequences. Huh? So the obvious or the easiest workaround is to use a different trigger. It's called the pull request target trigger. Basically what it means is that the workflow is executed in the context of the target repository, so basically your repository. There's a discussion also on the security lab blog from GitHub, where it explained that this is generally a very bad idea, and you should avoid that at most of the time. However, there might be cases where this is acceptable, when you also take additional precautions in order to prevent that really PRs from anybody is executed and accesses some of this sensitive information in your repository. Another link I wanted to provide you for information is a relatively neat way by a guy that came up with a solution to combine that trigger with additional user checks. If, for example, the person that created the PR is actually a member of the organization, of the repo itself. So then, of course, the trust level is different, and you would like to allow such a PR from being from letting workflows to run within the context of the target repository. But that's a very specific case. I don't suggest to do that on a regular basis, but there might be cases where this is appropriate. The bottom line, as I usually say, is, of course, you can do that, but use it with very much care. And the reason why I don't like that approach so much is because it requires you to think very hard what implications that has. And actually, you don't want that, because you just want to have workflows that work and don't require you to think hard about attack vectors. Another option that we also came up with help for a project in order to, for example, add code coverage information to PRs, which is, of course, very useful for any kind of PR. The option was there to actually split up the workflow in two. So we have a first workflow that does the actual work. So in this case, for example, generate code coverage information from the PR. Store the result as an artifact for the workflow run, and then trigger a second workflow after the first workflow is completed. And the second workflow is very simple. It just gets the information from which workflow it was triggered, downloads the artifacts from the first workflow, and because it has now write tokens, it can attach the comment to the PR. So why does this work? Is because with this specific setup, the second workflow actually runs in the context of the target repository, because it actually does not check out any code from the PR itself, but rather takes information that was generated during the first workflow run. So that's an option that is actually also suggested by GitHub. It's a bit tedious to set up, I have to say, because it requires you to set up two workflows. Here's an example how we did that for one of our projects. It's actually the U-protocol project for one of their specific repositories. You can take a look, get some inspiration, and see if this is also appropriate for you. I find it very frustrating that you come up with very sophisticated and fancy workflows, but they only work for your own PRs, not for PRs from contributors, which is a pain, because in the end, these are the PRs that you should actually support as well, because most of the time they need actual care and actual additional work to make sure that whatever would be merged into the actual repository follows certain guidelines, code coverage, metrics, whatever. Something that I wanted to mention here, and it's up for you to discussion also, maybe for the question section afterwards. There's something that we have set up now manually for, I think, one or two cases. But our idea is that we also would like to automate that. And at least the second workflow, I think we can perfectly automate that with the help of Autodoc. So if you like that idea and have ideas also for your own workflows where you would like to support that, come to us and let's discuss that. We can certainly find ways to automate that so that the need for a second workflow is actually not required, and we can do this automatically with some processing in our self-service that we operate on a regular basis. Okay, then not much time left anymore, but I wanted to give you some ideas for things we have done and to bring back some fun also with GitHub Actions, because I understand it can be tedious at times. Something that we did for some of the projects that they find very useful is to provide website previews for PRs. So usually projects have a website repo where they build the website that they would like to publish. And whenever there comes a PR from a contributor, they would like to see the immediate changes live. Some people use third-party services, Netlify, Gatsby, or how is it called? Yep. If people don't want to use that, and GitHub actually offers everything to do that yourself, you can do that. It's a bit tedious to set this up, but if you're interested, take a look into these projects, how they set it up for their project, or reach out to us so that we can help you set this up also for your project. It's, I think, worth to think about it. Another thing that we also worked on, it's still not yet integrated in the Eclipse Dash project itself. It's more or less in one of our personal projects, but we plan to integrate that into Dash licenses as well, is to have an improved Maven license check workflow that, first of all, gives you indication about the licenses that are not yet vetted, or the dependencies that are not yet vetted, directly in the PR, and also works for PRs from forks. So that's also the typical problem that many people have. The license check works perfectly fine unless you get a PR from a fork. So that's another example of that. Another thing that I wanted to share a bit with you is some really good examples of projects that use already the self-service to a great extent. The Eclipse Dancer project, for example, they came up with a very clean configuration that is very consistent for all their repositories. And basically, you see with their configuration how easy it is to do with our approach.
We have some happy users.
Yeah. So I'm really glad about that. Adoptium is actually, it was our POC project and the driver of this approach as well. They all have also a very clean configuration, and they also are quite happy users, I would say. Eclipse Zeno is also using this a lot to protect their repositories as much as possible. There's, of course, documentation on this link. You find all the information about how to set all the settings for all the resources that are possible to be managed by the service. If you are unsure, you need help, reach out to us. So we are usually quite receptive for these requests, either the chat service, help desk, or directly on GitHub. You can also open up discussions on our organization. So we have enabled this right now and would like to use that much more in the future. Okay, maybe a last slide here. What's next for us to do? So we would also like to further expand on the idea of policies. Policy in the sense of not things that you really have to do, but rather help you to do tedious or really things that you should have in your repository as much as easy as possible. For example, one of the things that we certainly want to push forward very soon is that that we have a policy that makes sure that there is a security MD file at least on an organization level. So if you don't have one specific in your repositories, at least there's one, maybe generic one, in your organization that is then inherited automatically by all your repositories. For example, another policy to make sure that the .github repository exists, because it's very useful, especially to create a generic security MD file. Add branch protection rules or rule sets for the default branch as a good practice. And any other idea or suggestions from your side are highly appreciated, and we would be happy to work with you to further improve the service to meet your needs, actually. Because I think that's also what we are trying to do, basically do something that is really useful and makes your life easier for you. Okay.
So unfortunately, I don't think we have time for questions, but we are there until tomorrow evening. Yeah. So feel free to join us, come to us, and ask us any question about that. And again, you can open discussions if you have any question for after the conference. Thank you so much for your attention. Have a good end of day.